Okay, so let's take a look at example 1 for section 9.3. We want to graph a quadratic inequality in two variables where a is less than 0. Okay, that means that a is negative, and we have a parabola that opens down. Okay, so we want to graph y is less than negative 2 bracket x minus 3 bracket squared plus 1, and then we want to determine if the point 2, negative 4 is the solution to the inequality. Okay, well if we want to graph this parabola, first we want to keep in mind that our vertex is at, and we are going to consider the numbers inside the bracket and on the outside. Okay. Alright, so number inside the bracket, negative 3, we want to take opposite sign, so our x value is 3. Keep our y value positive as 1. Okay, and I'll just code that for you. Okay, and we know that this parabola opens down, and we also know that because the absolute value of a is equal to 2, and therefore a is greater than 1, that we have a vertical expansion. Okay, which means that our parabola is going to be skinnier and longer. Okay, so let's graph this. We have a vertex at 3 and 1. So 3 and 1, and we have a vertical expansion of 2. I'll put that here too, a vertical expansion of 2. Okay, that means that our step pattern, remember our step pattern where we had the first step being a height of 1 and the next step being a height of 3, we have to double those values because our expansion is a factor of 2. So instead of moving 1 to the left and going down 1, so our step having a height of 1, we want our step to have a height of 2. And then from here, normally we would have a step of 3 if our a value was 1, but now we have a value of absolute value of 2, so we want to double that step of 3 and make it 6. And so we have a point here. And remember, because of symmetry, we also have a point right here and right here. Okay, so here we have a parabola that has a negative a value, which means it opens down. Our inequality is less than, which means that we want to graph below the line. And so we can go up to our chart up here. So we have a is negative, and we also have non-equal sign on here, right? Which means we're going to graph with the dotted line. So we want less than, so here's our less than row, dotted line. So we're going to be looking at this parabola. Okay, this is where a is negative and our inequality is less than and not equal to. All right, so we're going to use a dotted line to graph. Okay, and we want to graph below the line, so we're going to shade inside like this. And we are done, except for one thing. We want to test to make sure that we really do have the right region. So I'm going to choose a test point. And my test point is going to be this one right here. Okay, I'm going to, and once again, you can test any point inside the parabola, but I'll choose this one, which is at 3 and 0. So my test point is 3 and 0, and I'm going to plug it into the original inequality. Okay, so in place of y I will put 0, and in place of x I will put 3, and I get negative 2 times 0 squared, which is just 0 plus 1. And so I get 0 is less than 1. And is that true? Yes, it is true. So we can conclude that our shaded region is correct. It is definitely inside our parabola. Okay, so now we're going to take a look at our second question, which is to determine if the point 2, -4 is a solution to the inequality. Okay, so we will plug that into our inequality and the original one. And -4 for y, 2 for x, 2 minus 3 is -1. And so we're going to get -1 squared is 1 times -2 is -2. And so we get that -4 is less than -1. That is true. And so we can conclude that -2 and 4 is a solution to the inequality. Okay, and if you were asked to graph that, you could graph that point on the line, in our graph, 2, -4 right here. So it is inside our region. Okay. And as you can see, then you can test to see if this point is part of our region by graphing it on our graph, but more importantly, it's probably better just to work it out algebraically. Okay, so that's the end of example 1.